Welcome to the 10th installment of our Dutch landscapes lecture series. Today, two quick landscapes because, they're a very tiny part of the Netherlands, although the river deposit landscapes form a larger area. In fact, I can show it. But I'm going to roll them up into one lecture. Hopefully, it'll be around 20-25 minutes, maybe, hopefully even a little bit less. So what we've covered so far is the largest area, the sandy soils, yellow here. We have discussed the North Sea coast and the clay areas over there. And we've covered everything purple, which is the peated areas. And of course, this is a different type of peat than this. This is the wet peat areas, let's say, and this is the high and dry, the high fenlands, etc. The pale over here. So today, question: where are the dunes in the Netherlands? Well, they're everything yellow, and the largest strip of dunes is here, the North Sea coast of North Holland. And a little bit of South Holland as well, and Zeeland has got, but the dune strip over here is nothing really, it's just outer dunes. Okay, second question, what are dunes made of? Well, dunes are made of sand, SiO2, silicium oxide. So dunes are basically the same, made of the same stuff, they are the same soil types as the sandy soils. So another question, what type of landscape would look similar to dunes? Well, the relief-typed sandy soil areas, so the moraines over here should look similar. And what characteristics can we expect in a dune landscape? Well, sour soils, not a lot of water down there because it infiltrates. Not a lot of different types of plants and animals down there because, the ecosystem cannot support so much because the soil is very infertile. So there are four basic landscape types in the dunes. There's the outer dunes, which form the first line of defense against the sea. In Dutch, this is called the zeereep. And so you have the beach over here and the sea over there, and the sea, would overflow if these outer dunes weren't here. Then there are the young dunes. This is a beautiful painting of the young dunes. And that's everything behind this, immediately, directly behind the outer dunes. So outer dunes is the youngest dune. And in fact, you can see a new dune growing over here. Now in second grade, we've discussed extensively when we visited the dunes of Terschelling how dunes get formed. So I'm not going to go into that as much in depth as you might have wanted to. But basically, it's a constant inflow of sand from the sea. Wind blows it up on something on the shore, and then these plants, they root because they're pioneer plants. They don't need as many nutrients. They don't need as much water. They like these soury environments, these salty environments, in fact. And so they can live there, and they're the first line of defense, and then of course the dune gets bigger and you have an outer dune. Now the inner dunes, similar, irregular shapes, sand blows over the outer dunes into the backland and gets stuck in different types of vegetation. And here you find, seagulls and other types of birds. And, a young ecosystem is evolving, but it's still very rough and it's still very much a pioneer situation. Then in the old dunes, there's a stable environment, there's a stable ecosystem with flowering plants, with trees in fact, and these are the dune forests, so to speak. Mostly pine trees that were planted by humans, or trees that like soury environments, and we'll see what that is. Then there is the fourth strip in the west of the Netherlands, and this is what the Netherlands is famous for, the flower bulb fields, and these are laid out in Geestland. So what a Geestland is, we'll talk about that very quickly in a couple of minutes. But first, if you have a strip of dunes from the North Sea reaching inland, let's say Beverwijk, Castricum, Limmen, Alkmaar is a little further north. Then the dunes would look sort of like this. The outer dunes are the first line of defense, right? Then there is the inner dunes, very rough environment, pioneer vegetation, not a super stable ecosystem yet. These are the guys that build up the humus for the large trees that grow over here and the other plants that live there. So not many nutrients, in fact, almost none. And then these plants die and they build up the humus in a very similar way as we've seen the sandy areas build up into a brown forest tree soil or a podzol soil. All right, very, very similar way of building up topsoil in here. And then there is Geestland, and they did something crazy with the Geestland. Okay, what happens in the Geestland? Okay, so sorry, I'm going too fast. The Geestland will be the next slide, I think. Here is a guy looking at a soil. Of course, this is the outer dunes. This is the stable environment, and as you can see here, it's very dark. And then there is this, the dune sand. So there is topsoil here. The outer dunes, there is no topsoil here, and you can see beautifully the way the wind lays out these packages of sand. Sometimes the wind comes from one direction, and you have this, and sometimes the wind comes from another direction, and you have that. This is what we call the criss-cross layering of the sand. Every time you see this, you know that you are not in a marine environment. If you see this in a type of rock, in a piece of rock somewhere, I mean, you're being a geologist and you're hammering open a rock and you see this type of layering, you know, not in the same direction at all, the crisscross layering, you know that this was a environment where the wind was the method of deposition and not the ocean, because the ocean will only flow in from one direction. And so you'd have the same layers in the same direction always. And anyway, so in the outer dunes, there is almost no humus. Nothing can grow there except the pioneer plants. And then, of course, the old dunes, they have built up topsoil and other plants move in and take over and forms a stable ecosystem. Right, now what did it do with Geestland? Well, basically, what we've seen before is that the ocean builds up the dunes, right? We have a period where there are depositions of old dunes, let's say in 7,000 years ago. The old dune deposition was formed, and then afterwards the sea broke through in a transgression, and there was a water sea sort of thing, and then the peats came back, and then the young dunes were formed as well. And so what we have in many cases in the Netherlands, Beverwijk, Heemskerk, Castricum, Limmen as well, Alkmaar, is that the people who started to build their towns, they built their towns on the old dune depositions far inland. Because why? Well, they were drier and higher than the surroundings because they were an old dune deposition, so they were quite a bit higher. And they were made out of sand instead of the harsh clays, the heavy clays and the heavy and the peats. So the land was easier to use. You know, if you have a very heavy peat, it takes a lot of effort to put your shovel in and to put it around, and it's just the clay sticks together a lot, and it's hard to work the land. Well, if you have sand mixed up in there, it's easier to use the land and to put your shovel in, and it takes less of an effort to plow the fields, etc. So that was one of the reasons why we see all these at the same place. Also because this is very infertile. All right? But another reason is that the old dune deposition has a lot of lime in it. And lime is fertile. So if you have lime-rich sand, the sand is going to make it not so fertile because it's only SiO2. If you mix it up with a little bit of lime, it's going to be good for certain types of plants. Now, the young dunes deposition doesn't have a lot of lime in it. It's lime deficient. So if you want to make something of this land, you have to add fertilizer or lime, in fact, on this land to do something. But, people didn't know about it way back in the day when the tradition of growing plants and this geestland was started. So what they did is they just excavated. They just dug a hole. They got rid of the lime-deficient young dune depositions over here. The first layer was just dug out and excavated by the sand. And then they reached the lime-rich sand of the old dunes deposition, and there we have the ideal circumstances for the tulip to grow. Now, the tulip is a flower that comes from Turkey, I believe. And so they imported the tulip and made it a Dutch hallmark, a Dutch icon, even though, it came from a different country. And the tulip has a very interesting history that I won't tell, but the first huge crisis, economic crisis in a country, the first huge bubble where people were paying huge amounts for something that really wasn't worth it, was the tulip mania. In the Dutch golden ages, people were paying extreme amounts and gambling their money on the rising of prices of tulips in various colors, and some people made a huge amount of money, and most people eventually lost a huge amount of money when the bubble in the prices of these tulips had inflated so large that it burst, and suddenly nobody wanted to pay that extreme amounts of money on tulip bulbs anymore. The tulip mania, it's a really interesting story, and it all started with excavation of these old dune depositions. Excavation of the young dunes into the old dunes, and so people could grow them. Interesting story to find out. Now, another good thing about dunes is that they filter water, right? I mean, if it rains here, the water falls into the dunes, which is, sometimes 50 meters high, and it falls through the sand, and that sand filters the water, so there's a large bubble of sweet water underneath the dunes, and you can pop that up and use it to drink it. You don't really have to get rid of any microorganisms in there because it's very clean water. It's very good stuff. And this is a natural basin for a lot of sweet water in the Netherlands. Now notice that the water table is not straight. See, the water table rises with the dune and goes down again when the dune stops. Now, this is not a bad drawing. This is capillary working. So, if you have a large body of sand on top of soil, the water will actually creep up in there. And it's got to do with the physics of water and the physics of soil. So it's called capillaire werking in Dutch. Maybe you've heard about it in physics classroom. It's capillary. Yeah, if you want to know more about it, I suggest you Google it because it's not really that important for now. Anyway, should you notice this in drawing sometimes of dunes, then you know it's not a mistake. It's actually what happens. The water table here is a lot higher than the water table over there. All right. On to the river deposit landscapes. Same basic questions. We've covered the dunes, which is, the sort of S shape of the Netherlands, the sort of logistic feature. And we've covered the clays, we've covered the sands, and we've covered the peats. And so the only thing that we have to do now is the river deposit and Zeeland and West-Friesland, because those are really weird areas, and of course southern Limburg. So the river area is over here, the IJssel River, the Rhine comes in, the Meuse comes in, the Scheldt is over here, and the river area is this, and this is formed by the overflowing of rivers. Now, what does a river bring? Well, it brings normally in low-lying floodplain sands and clays. So what characteristics can we expect in a river landscape? Well, we can, similar features as we've seen in the clays. Clay is fertile, whether it's sea clay or river clay, doesn't really matter that much. You can use river clay a bit quicker because it's sweet water and This, of course, is salty clay, so you have to get rid of the salt first and lay it out for a couple of decades. But clay is good stuff. I mean, a lot of plants will grow on clays. And how did these river landscapes form? Well, rivers have crazy behavior, especially in lowland areas. They tend to not stick to their bedding. This is a famous Google Earth picture. It's about 30 years of river from 1984 to 2012, and you can see that the river is constantly changing where it flows. And the quote, as an hydrologist, this is porn to me, was put on Reddit with this picture where I found it, and I thought that this was a beautiful quote because, yeah, this river, I can not look at this for hours, but I can look at this for a long time, and this behavior of rivers obviously has an influence on the landscape. Now, this behavior is called meandering, and meandering is named after the Turkish river, the Meander, who does this in an extreme way. And the Greeks, when they conquered Turkey, they saw this and they said, well, how do you call this river? Meander. Okay, then now everything with curvatures and bends and not keeping a straight line, we're going to call that to meander. It's a verb. And this river is really doing this in a weird way. And sometimes it cuts off old river bends, like this one. Used to be the river flew this way, but it broke through apparently here. This is where the river used to flow. And it broke through its own bed and cut off this oxbow lake, this oxbow-shaped lake. Here it did the same thing. And now you have these oxbow lakes. This is what they are called. Right? So the question is, why do rivers do this? Why do rivers curve? And there's a good reason for this.
Compared to the whitewater streams that tumble down mountainsides, the meandering rivers of the plains may seem tame and lazy. But mountain streams are corralled by the steep walled valleys they carve. Their courses are literally set in stone. Out on the open plains, those stony walls give way to soft soil, allowing rivers to shift their banks and set their own ever-changing courses to the sea. Courses that almost never run straight. At least not for long, because all it takes to turn a straight stretch of river into a bendy one is a little disturbance and a lot of time. And in nature, there's plenty of both. Say, for example, that a muskrat burrows herself a den in one bank of a stream. Her tunnels make for a cozy home, but they also weaken the bank, which eventually begins to crumble and slump into the stream. Water rushes into the newly formed hollow, sweeping away loose dirt and making the hollow even hollower, which lets the water rush a little faster and sweep away a little more dirt, and so on and so on. As more of the stream's flow is diverted into the deepening hole on one bank and away from the other side of the channel, the flow there weakens and slows. And since slow-moving water can't carry the sand-sized particles that fast-moving water can, the dirt drops to the bottom and builds up to make the water there even shallower and slower, and then keeps accumulating until it becomes new land on the inside bank. Meanwhile, the fast-moving water near the outside bank sweeps out of the curve with enough momentum to carry it across the channel and slam it into the other side, where it starts to carve another curve, and then another, and then another, and then another. The wider the stream, the longer it takes the slingshotting current to reach the other side, and the greater the downstream distance to the next curve. In fact, measurements of meandering streams all over the world reveal a strikingly regular pattern. The length of one S-shaped meander tends to be about 6 times the width of the channel, so little tiny meandering streams tend to look just like miniature versions of their bigger relatives. As long as nothing gets in the way of a river's meandering, its curves will continue to grow curvier and curvier until they loop around and bumble into themselves. When that happens, the river's channel follows the straighter path downhill, leaving behind a crescent-shaped remnant called an oxbow lake.
Or a billabong.
O un lago en herradura.
Ou un bras mort.
We have lots of names for these lakes, since they can occur pretty much anywhere liquid flows, or used to. Which brings up an interesting question. What do the Martians call them?
This Minute Earth video.
Yeah. All right. So rivers have been meandering and, moving around in the Netherlands for a long time. We've seen that they did it in the pre-glacial. We've seen that they did it in the Holocene. And if people wouldn't be people and let the rivers do whatever they want instead of building dikes, they would still do it today. Of course, we don't like it when the rivers act unpredictable, because then, we drown. So what we do is we build dikes and we restrain the river to its bedding. More on that in a second. But what we do know is that the Rhine, which currently flows in this direction, and of course a little bit in this direction, the lower Rhine. And this is the Amsterdam Rhine Canal, and this is the Waal Rhine Canal. Anyway, used to flow in various times in various different areas. So there was a time when it was the Red Canal. Now this is not so long ago. There was a time when it was the Orange Canal. It was longer ago. There was a time when it was the Green Canal. Anyway, and Mr. Berendsen, who is now dead, unfortunately, but he did a lot of research on the Dutch landscape, and he mapped this, together with Mr. Stouthammer, this map of all these, former river flows by digging holes in the Dutch landscape and actually looking at the sediment that he found. And he found sands. He knew that he was close to where the river bedding was, and he found clays. He knew that he was pretty far away from this bedding. Now, how did he know that? So what Berendsen did is he thought of as a river as a canal where water flows through, and water carries sediment. And what he said was, well, if the river overflows, then the stream speed is going to take down. The further you are away from the bedding, where the stream speed is going to be highest, the stream speed will go down the most. So over here, the stream speed is the lowest, and over here, the stream speed is the highest, and these are various stages of intermediary speeds. Now, the biggest particles in the river will be heaviest and will therefore need the highest speed to flow through. So the further I am away from these stream speeds, the smaller the particles are. Now, coarse sand, of course, is a lot bigger than clays. So the further I go away from the bedding, the more likely I am to find clays. And the closer I am towards the bedding, the more sand I should be finding. Because every time the river overflows, it drops a bit of sand over here first, and the smallest particles, only the smallest, will be over. So there's less sediment here, and most large particle sediment will actually fall down closest to the riverbed. So if I drill anywhere in the river area of the Netherlands and I find sand, then I know that I'm drilling into a natural levee close to the actual bedding of the river. There used to be a river there. And if I find only clays, then I know that I'm very far away from the river bed. And if I find a section where there is first a lot of clays and then there is sand, then I know that there was a river there a long time ago that has now been buried by new areas where clays have been deposited. So the river moved around to another area and then dropped its clay content over the old river bed. And so he mapped down 12 meters of area and found actually several places where these river beds overlap. There was a river here, then the river moved over there, and then there was a river there, and then there was a river there, and so on and so on. So this is how he mapped this. Okay? Drilling, seeing what sediment you find, and then drawing a conclusion. And this is the situation right now. These are the canals where the water is flowing through. And close to the canals, of course, we find the natural levees. the creek ridges, as they are called. And these are made of mostly some sands, and of course there is some clays mixed in, but let's say that they're called sandy clays, all right? And then the further you go away from these canals, the more likely you'll find the heavy clays. Only clay particles. This is land that is really going to be hard to plow because there's clays and they stick together and it's massively filled with a lot of water and it's hard to work the land there. It's easy to work the land here, which is why we find the settlements. We tend to find them on the river banks. Also because the river, is easier to use as a method of transportation. Boats, trade, etc. tends to take place on rivers a lot. So, two reasons basically. One is for trade, and the other, of course, is because the land is easier to use. All right, so there is different types of land use, just as we've seen in the dunes, and various different types of these areas. By the way, the natural levees and the creek ridges, they are called oeverwollen in Dutch. And that's only the natural levee, okay? Oeverwollen. They're formed in a natural way. Okay, and the floodplains are called the komgronden. So this is the biggest kom, this is a big kom, and then the oeverwollen are over here. Right, so on the oeverwollen, on the natural levees and then on the creek ridges, they have fruit trees, mostly apples and pears. The Betuwe is where most of our apples and pears come from. Now, you may have noticed that around our school are farms who actually also have apples and pears. There's a good reason for that. We'll see it when we discuss Zeeland and West-Friesland in the next episode. So don't go away. You'll find out what's going on there. But in the floodplains, in the depressions, in the clay area, it's hard to work the land. So what they do is they put cows there and grass. That's it. Even though the clay is extremely fertile, it's very wet. And again, as we've seen in the peat areas, crops will start to rot here because there's too much water. And also it's very, very hard to plow it every year. And it's a lot of work. It takes a lot of energy. And so it's easier to just put cows there. They eat the grass, and it doesn't really matter if the grass, roots rot, because grass can grow in areas where it's very, very wet indeed, and they don't have the problems with the fungi and the rotting of the roots as much. And even though we cannot eat grass, cows can eat the grass, and then we either eat the cows or better yet, we make cheese out of the milk and then eat that and then say, that's good cheese. All right? So I already preluded to this. We tend to think of rivers as, dangerous. Rivers can overflow, and they do so regularly. And if we don't build dikes or use defenses against it, a lot of people in the Netherlands will be bothered quite a bit by overflowing rivers. We tend to think of rivers as nuisances. And what we do is, of course, we build dikes. So there's a dike over here. And also, we don't want these rivers to meander more and break through the dikes, right? If nature would have its way, then this corner would become bigger and bigger and bigger. And this corner also, and this boat would have a lot more. I want to say sailing to do, but it's not a sailboat. Anyway, it has to go further around these bends, right? And we like a straight line because it's less energy and less time, and time is money in our economy. So if we have nature have its way, these houses eventually have to go away. So what we do is we try to break the stream of the river using these groins, as they are called. And so the river flow comes in here and then gets broken down, and the river becomes a little bit more lazy, and less erosion takes place in this corner. And so the river is more stable in in the course. And of course, these dikes make sure that the river doesn't overflow as much. But we know for a fact that rivers carry sediment. And the sediment will be dropped every time the river gets out of its bedding. So if you have a river that drops its sediment in between the dikes, then eventually, after a long time, the area between the dikes will be higher than the area surrounding the dikes. The bedding will be higher than the floodplains. And of course, that is what makes a river extra dangerous. Because now if it overflows, a lot more land behind the dike is going to be in danger. Okay? We are, in the Netherlands, pumping our polders further down, and the rivers are raising the beds of their the currents higher. So on the one hand, our livable space becomes lower, and the danger of the water becomes higher. And that is even excluding global warming. Okay? We are pumping ourselves down. Global warming is raising sea levels, and the rivers themselves, they raise their own beds because they are unable to flow freely out into the open. And this is becoming a problem, which is why in some cases we see the Ruimte voor de Rivier projects, where the river gets more space to flow, and the narrow canals between the dikes are actually broken up, so that if there is a large amount of water flowing in, then the river has some more space. It's called Space for the River project, and we tend to give back a lot of farmland to these wetland areas, which is also good for biodiversity, etc. So there are some issues with the river landscapes at the moment because of the behavior of rivers and the way we planned our land.